Understanding the sequence of operation when diagnosing a furnace is crucial for several reasons. 1. Identifying normal versus abnormal operation. This understanding helps pinpoint where in the sequence the problem occurs, making it easier to diagnose and fix the issue. 2. Systematic troubleshooting. Technicians can follow the sequence step by step to identify and address malfunctions, ensuring no steps are missed and reducing the likelihood of misdiagnosis. 3. Safety. Understanding the sequence ensures that safety protocols are followed, preventing electrical shocks. 4. Efficiency and accuracy. It minimizes guesswork and helps technicians quickly identify faulty components, reducing downtime and repair costs. 5. Customer satisfaction. A well-functioning furnace provides consistent comfort, which is a primary concern for homeowners. The electrical sequence of operation is how the electric voltage flows through the system and can be shown on a schematic diagram. Whereas, the component sequence of operation is the order of components. For a furnace, the component sequence of operation is typically: call for heat, inducer motor, pressure switches close, igniter, gas valve energizes, flame rectification, blower motor energizes. On modern-day furnaces, the CPU, also known as the microprocessor, determines the timing to energize a component. The CPU receives inputs and makes a decision for outputs. Now let's apply the component sequence of operation to the electrical sequence of operations. The call for heat is initialized by a thermo switch in a thermostat. The voltage is conveyed to the W terminal. The CPU receives an input and branches to the pressure switches. The CPU must confirm that each pressure switch is open before the next sequence. The CPU closes the IDR contact, and voltage flows to the HSIR and inducer motor. The inducer motor consumes power and then returns back to its source. The inducer motor creates a negative pressure and closes the pressure switches. The voltage conveys through the HPS, and the CPU receives an input proving the HPS is closed. The voltage conveys through the LPS and branches off the GVR, HUM, and an input to the CPU proving the LPS is closed. The CPU output closes the HSIR, conveys voltage to the HSI. The HSI consumes power and must return to its source. After a set time in the CPU output closes GVR, conveying voltage to the gas valve. The gas valve consumes power and must return to its source. The gas is ignited, the CPU receives an input from the flame rectification. The CPU removes the output signal to open the HSIR. After a set time in the CPU output closes BLWR, opens BFANR, and closes BHT. The blower module receives the 24 VAC input and finally the blower motor energizes. Thank you for watching. Schematically applying the sequence of operation.